Okay. So the next part asks me to draw the graph of a bunch of functions. Let me actually use a website to draw that for us. So the interactive graph website that I'll usually use, this is called demos.com. It's just like a demos with the S. Okay, so this is what the its homepage looks like. So it's just desmos.com. You can also try along if you wanted to. So let me go ahead and start plotting these graphs. It takes longer than I expected. Um, okay. So the first one, I'd like to try f of x equal to x. So let me just put x. And well, this is just the what we typically expect. Let's see. Okay. So the graph of f of x equal to x is just going to be a straight line. It's going to have a slope 1. So for all the points on this line, you'll see that the y value is the same as the x value. So well, just the graph of y equal to x. That should be pretty simple. The second one, I like to draw the graph of 2x plus 5. So you get the blue graph. So if you remember this kind of graph, this is called the linear function. The 2x, the 2 tells you the slope. That just means each time your x value goes up by 1, your y values go up by 2. You can kind of see that each time it goes up by 1, y goes up by 2. The number 5, it tells you the y-intercept. So that's going to be where my graph intersects the y-axis. And again, you can kind of see that for all the points that you have on this line, if you multiply your x value by 2 and add it to 5, you'll get the y value. Like when your x is 0, 2 times 0 plus 5 is 5. When your x is 1, 2 times 1 plus 5 is 6. Wait a minute. 2 times 1 plus 5 is 6. Oh, yeah. I mean, it's 7, sorry. Yeah. When your x is 1, is here. This graph is just funky. Okay, so this might be better. When your x is 2, your y value is going to be 9, and it keeps going. So that makes sense. Now, generally, if I try to draw a general graph of a function ax plus b, this is what you're going to get. So you get the green line. Your b value, let's do the b first. The b is easier one. The b value tells you where your graph intersects the y-axis. So you can kind of see as I change my value of b, my graph is going to have the same slope, but where it intersects the y-axis is going to be the same value of b. So here is around negative 3.8, so that makes sense. When it gets closer to 0, you should see that it crossed the y-axis at the origin. And then when my b is positive, it's going to intersect the y-axis when the y value is positive. So let me just leave it at, let me see, I would like integer better. Okay, so that's 4, so that makes sense. My a value, this is the value of the slope. So let's see what happens when I change that. If I increase my a, that means my graph is gonna slant it more. Wait, come on, keep going. Okay. So when a is, so you can kind of see when I change my a, it doesn't change where my graph intersects the y-axis. But if I increase my a, it's gonna make my graph more slanted. So when my a is 10, that just means when my x go up by 10, my y, when my x go up by 1, my y would have goes up by 10. So that's what you get. And then, let's see, when my a is 1.2, yeah. When my x go up by 1, my y goes up about by, well, you can kind of count number of blocks. When my x go up by 1 block, my y goes up about by 1.8 blocks. So that makes sense. When my slope is 0, when my a is 0, you'll get a flat line. Okay. So this is what happened when your slope is 0. And then when my a is negative, your graph would have slanted down. So that's the graph of a linear function. You will have two parameters, the a and the b, the slope and the y-intercept. Well, since I'm already here, let me skip this the next example momentarily. Let me show you the graph of these guys. I'm just gonna open a new tab to sketch the graph for the next set of example. Okay, so I have x squared. So that's your typical parabola. Your x cubed. So that's the blue graph, you can kind of see. And then the next one is the square root of x. You get the green graph. Let me actually zoom in a little bit. One. So you can kind of see square root is not defined for negative numbers, so that's why the green graph stops at the 0. And the last one, I have 1 over x. So the orange graph is the graph of 1 over x. You can kind of see when my x increase, my y would decrease, and when my x equal to 1, my y would equal to 1, and when my x remain positive but decrease, my y would increase, and it will keep going up all the way. And the opposite things happen when my x is negative. So I would expect you to memorize or to know the graph for these basic functions. Now, all these kind of functions, it belongs to the same category of functions. They are called the power function. So let me kind of do the general case here real quick. Let me draw the graph of x to the a. So it's kind of funny to see, but you can kind of see when my a is 2, you get parabola. When my a is 3, you get the x cubed graph. When my a is 1/2, you get the when my a is 1, you get linear graph. So that's pretty simple. When my a is 1/2, you get the square root that you have, and when my a is negative 1, you get the 1 over x. Show up, okay. So that's my next example. For the last one, deals with exponential function. Okay, this is your, so e to the x, this is your typical exponential function, so it looks like that. And then the next one is 2 to the x. 2 is smaller than e, so it's gonna grow slower than to the x. So, but it's gonna have the same shape anyway. So the blue graph is 2 to the x, the red graph is e to the x. If I do 1/2 to the x, 1/2 to the x, 1/2 to the x. Okay. So 1/2 to the x is going to be the mirror image of my blue graph. And this is kind of because when x is negative, your 1/2 to the x is going to be the same as 2 to the x. So once again, all these graphs, it belongs to the same category of graph. They are called the exponential function. So generally, it's going to look like a to the x. So in contrast to the power function, here my x is in the exponent. So typically, it doesn't make much sense if your a is negative. But when your a is positive, you can kind of see. So when my a is less than 1, it would look like your green graph. Or when my a is 1, it's going to be just 1 to the x, so it's just all 1. When my a is less than 1, it's just going to look like a green graph. When I increase my a, it becomes flat. And when my a is bigger than 1, it's going to look like the your blue or my red graph. It depends on how big my a is. You can kind of see the bigger the a, the faster my graph would grow. Okay. So I'm gonna post a link um, to this interactive graph in case any of you want to play with it.